So today in class we talked about how we can take data and put the data into a graphical display and then notice things about that particular display and about the data. We're going to learn some more terminology to help us kind of summarize what our charts or what our data is trying to tell us. When we talk about measures of center, we're talking about the 3 M's, which would be our mean, which is the average, the median, the middle number, and the mode. So to calculate the mean, we would take the average, which is we're going to add up all of our numbers and divide by how many numbers we have. The median is the middle number in an ordered set. So we need to make sure that our listing of data goes from least to greatest, and then we're going to go ahead and take the middle number there. If we have an odd number of data points, it'll truly be the middle value. If we have an even number of data points, then it's going to be the average of the 2 middle numbers. And then mode we talked about a little bit. It's just the most reoccurring number, and some sets of data will have more than one mode. Let's take a look at data. I surveyed my methods class about the number of books they read for pleasure last year. Below are the results. We're going to first construct a line plot of the data, and then we're going to go ahead and do a couple calculations. So I can see that my data, the lowest value is 1, and the greatest value is 32. So I'm going to make my chart. My number line is going to go from 0 to 35, so I'm going to go in jumps of 5. So I went ahead and divided up my line from 0 to 35 into individual tick marks. And now what I want to do is I'm going to place dots wherever I see that number occurring. So I have a 1, so I'm going to put a dot. 5, a dot. 12, a dot. And so on. So I should have 13 dots here. And remember, with our dot plots, we always want to have a title or label. So I'm going to have my title here, number of books read last year. And then what I want to do here is I'm going to determine the mean, median, and mode of my data. Let's take a look at mode first. Mode would be the most reoccurring number, and I see that I don't have any repeats here. I have every dot value is just at a single layer. So I really don't have any modal numbers, so I have a mode of none. Then I want to go ahead and determine my mean. To calculate the mean, what I'm going to do is I'm going to add up the numbers that I have here. That ends up equaling 170. And I'm going to divide that by the total number of items that I have, which is 13. And that's going to give me a mean value of 13.1 if I round it to the nearest tenth. So my mean value is going to be 13.1. And then the last thing I need to do is I need to calculate the median. To calculate the median, I need to have an ordered list. And so whether I have the numbers listed out here in order or I could look at what I have here. I said I have 13 books, 13 dots. So really the middle dot would be my 7th dot. So I'm just going to go and count over my dots. I have 1, 2, 3, 4, 5, 6. My 7th dot looks like it's right here on 11. So it looks like my median value is going to be the number 11. To check myself, I can list out the numbers that I have in order. So if I wanted to do that, I could list them out here. I have 1, 3, 4, 5. 1, 3, 4, 5. And then I have a 6 and an 8. And then I have my 11 and 12. And then I have 15 and 18, 25, 30, and 32. So that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'm going to go over to my seventh value, which is going to be 1, 2, 3, 4, 5, 6, 7, which was 11. So I calculated my mean to be 13.1, my median was 11, and my mode, I didn't have a modal number. And then the question says, which measure of center best represents this data? So what do you think is the best average for this particular data? Here, the mean and median are somewhat close. I feel like whenever we can possibly do it, we should try to use the average number unless we have some extreme values. So I feel like in this particular case, the mean might be the best measure of center at 13.1. So the average number of books read was approximately 13 books. All right, let's take a look at an example. This here is a long jump example. A new coach has been working with a long jump team for a month, and the athlete's performance has changed. So for example, Augustus can now jump 0.15 meters further. June and Carol both can jump 0.06 meters further. So they've grown in the length that they can jump. Here we have some data, and we can see that everybody is positive except for we have Sam here. Sam has actually jumped worse than what he was jumping previously. So the first thing we're going to do is we're going to go ahead and make a dot plot of this. And you can see I have a dot plot labeled here. It needs to go from a little bit less than negative 0.5, and it needs to go to 0.2. And I'm just going to kind of estimate. It's not going to be exactly precise. I'm not going to put all the tick marks in there. We just want to get an idea of what it's going to look like here. So with Augustus, he's at 0.15. I have that marked off, so I can put his dot right there. And then I have June is at 0.06, so this is 0.05. 0.06 is going to be just right next to that. And then I have Bob is at 0.12. If this is 0.1, 0.12 is going to be right about there. And I have Tom. He actually jumped a little bit, or his distance was very, very close to Bob's, just a little bit less, so it'll be at 0.11. Carol is the same as June, so we're going to have a stacked dot here. And then Sam actually got worse. His point is over here at negative 0.0 or negative 0.56, so we're going to put him right about here. I changed colors on us here. All right, so from this dot plot we can see a couple of things. We can see that we have a mode here because we have two dots that are stacked. I'm going to say that my mode is at 0.06 meters. I want to calculate my median and my mean. To calculate the median, it's going to be the middle number. In an even set of numbers, it's going to be the middle two numbers. So if I was to count over, going from left to right, I have 1, 2, 3, 4, 5, 6. I need the middle, if I go in 3, 1, 2, 3. So I'm going to use, this is one of my middle numbers. I should change the color. This is one of my middle numbers here. And if I go the other direction, 1, 2, 3, I'm going to have this value. So my median is going to be the average of 0.06 plus 0.11. I want to average those two numbers together. That gives me a value of 0.17 divided by 2, which is really 0.085. That's my median value. Again, I had to average the two middle numbers because I had an even number in my set. So now the last thing I need to do is to calculate the mean. And to calculate the mean, I am just going to add up the total values I have and divide it by 6. So when I go ahead and add those up, I get a value of negative 0.06. I'm going to divide that by 6, which gives me a mean value of negative 0.01. So I have an average measure of center that is negative. Notice that my measures of centers are really off. The mode is at a positive 0.6, which is somewhat close to this positive 0.085, but then my mean seems much different than the other two values. So it says, on average, the performance went down. The coach is obviously useless, right? Well, we just had one student whose value went down. All the other values increased. So what we would actually identify Sam's score as is an outlier. You can see that from the data that was plotted, it is really, really, really far away from the rest of the data. And we term that as an outlier. Anytime we have a value that is really far away from other values, we consider it an outlier. And a lot of times when we have outliers, they will affect the mean value because the mean takes into account all of the values used. So because we can see that Sam is an outlier, let's not use his data. Let's eliminate his data from our calculations and take a look at our mean and median now. So if we eliminate Sam from the data, we only have 5 data points that we're looking at, and we need to find the middle number. So if I'm counting over my values here, I have 1, 2, 3, 4, 5. So 3 this time would be my middle, or this third dot would be my middle number. And we know that that dot is the value 0.11. So the median is saying it is 0.11. And now I'm going to go back up to the data I had here. I'm going to eliminate Sam from my total. I'm going to add up the 5 other values and divide by 5 and see what my median is. I added it up. I got 0.5 divided by 5, so my mean value is going to be a value of 0.1. Now look at how close those two values are. My mean is 0.1, my median is 0.11. They're super close, which makes a lot more sense. We would expect our measures of center to be close together. So what you want to notice is that when we took Sam's value and we added it in, it had a really big effect on the mean. So what effect does an outlier have on the mean? It's going to pull the mean in one direction. So in this case, Sam's value pulled the mean down. It made the mean much lower than what it was before. So here without Sam, I have a positive 0.1, so 1/10 of a gain. And when I had Sam's value in, it was a negative 1/100th. So very different values. The median, however, didn't change much. It changed a little bit. It went from being a 0.08 to a 0.11. So both of these values are positive. This one here is like a tenth, a little over a tenth closer. So it has a little effect, but not much. So what effect does the outlier have on the median? Not much. So anytime we have an extreme value like an outlier, it's going to affect the mean because we actually use that value in our calculations. We're adding it in. Where the median, we're just counting over so many places, so the effect will be minimal. So we looked at measures of center, and now we're going to take a look at measures of spread. The measures of spread are range, which is going to be the difference between the highest and lowest terms. Something called the interquartile range, which is going to be the difference between higher and lower quartiles. Quartiles pretty much divide our data up into 4 equal parts, like a quarter, a quartile. It's going to divide it into 4 equal parts. And the interquartile range will be the difference between the third quartile and the first quartile. And then standard deviation is the average distance from the mean. We will spend some time in class on Friday, at the end of class on Friday, taking a look at standard deviation and how to calculate it by hand, and then how to use a calculator or Excel to help find it for us. So to take a look at the idea of spread, we're going to take a look at a graphical display, which is called a box plot. And this display is used to graph quantitative data, and it really gives you a good view of spread, whether we're talking about the range or the interquartile range. To create a box and whisker plot, you have to find something called a 5-number summary. And the 5-number summary consists of the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. Once we have those values found, we'll make a rectangle using those upper and lower quartiles. And then from there, we're going to draw some whiskers or lines from the sides of the rectangle to the minimum and maximum values. And then we place a line inside our box, and that's going to be our median value. So let's take a look at some data, see if we can calculate the range, interquartile range, and the 5-number summary. The data we're going to take a look at is the heights of the players on the Cavs team. I have the heights listed out here in inches, and we have, I think, 17 players here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The first thing we need to do is we need to arrange this data in an ordered list going from least to greatest. So let's take a moment to go ahead and do that. I can see that my lowest height here is 74 inches, and it looks like my highest height is going to be, I think, 84 inches. So I was able to organize my list from 74 to 84, and then from there I'm going to go ahead and fill in my 5-number summary. So my minimum value is 74. My maximum value is 84. And then I want to calculate my median. My median is going to be the middle number. I said that there are 17 players, so if I count over 8, 1, 2, 3, 4, 5, 6, 7, 8, this is my 9th place. If I count the other direction, 1, 2, 3, 4, 5, 6, 7, 8, so 79 right here is going to be my middle number. So my median is 79, and because I'm using that number, I'm going to cross it out, and now I have my data divided into a lower set of values and a higher set of values. So my lower set of values, I have 1, 2, 3, 4, 5, 6, 7, 8 values there. I want to calculate the median of this lower set. So of this lower set, 1, 2, 3, 4, 1, 2, 3, 4. So my middle two numbers in this lower set is 76 and 77. So I'm going to go ahead and take the average of 76 and 77. So 76 plus 77 divided by 2, which would give me 76.5. So my lower quartile is 76.5. And now I'm going to do the same thing for the higher part of my data, or my upper quartile. So here I can see that I have 8 values, 1, 2, 3, 4, 5, 6, 7, 8. I need to take the middle two, 1, 2, 3, 4, 1, 2, 3, 4. So it looks like I'm going to be averaging here 82 and 83. So I'm going to take 82 plus 83 divided by 2. That's going to give me 82.5. So my upper quartile is at 82.5. So from here, I have my 5-number summary. From my 5-number summary, I can pick out some important information, like I know that my range of values, because range is the difference between highest and lowest, my range of values is going to be 84 minus 74, which is 10. So my range is 10. My inner quartile range, which we call the IQR, the inner quartile range is going to be the difference between Q3 and Q1. The difference between Q3 and Q1. So these two values. So I'm going to go ahead and take 82.5 minus 76.5, and that's going to give me a value of 6. So I have those two values. And now I also want to go ahead and create my box plot. So to create my box plot, I need to create a a number line, and I'm going to take a look here at step 2. So what I actually need to do is I need to just erase a little bit of this information so that I have room to go ahead and draw my box and whisker plot. Alright, so I'm going to go ahead and add in a number line here. And I can see that my values are going to be going from 74, so I'm going to go 70 to, I'm just going to go 70 to 90. So I have 70, this here is going to be 80, 90. Here's my 75, here's my 85, and I'm just going to put in some marks then. All right, so now once I have those values in, I'm going to go ahead and mark some things off. It says here that I want to make a box or rectangle out of the upper and lower quartiles on the number line. So they're going to be the sides of my box, and my upper quartile was 82.5, so 81, 82.5, so it's going to be right up here. And then my lower quartile was 76.5, so that's right around here. So I'm going to make a rectangle. The rectangle is going to be above the line. So this here is my rectangle. I used my upper and lower quartile to make that. And then it says that I am going to need to draw a line inside the rectangle at the median value. There will be times where that median might not be in, it might be like an edge of your box. But here, because my median value is 79, I'm going to go over to my box, and at 79 I'm going to put a line in there. That's my median. It's at 79. And then I'm going to end it by drawing the whiskers. The whiskers are going to be connecting your minimum value to the side of the box, the maximum value to the side of the box. So I have a minimum value at 74. I'm going to put a dot there, and I'm going to connect it to my box. And then I have a maximum value at 84. I'm going to put a dot there and connect it to my box. And this is what your box and whisker plot looks like. The only thing I would add in here is along the bottom I'm going to have a title that says height in inches. And then we would want to have a title, and that would be height of Cavs players. And that's our box and whisker plot. So from our box and whisker plot, we were able to determine our spread, which was the range of values, which was from minimum to maximum. We also looked at our inner quartile range, which was really the distance or the length of this box. And then we saw one of our measures of center, which was our median. From the data here, we can see that our mode, the most reoccurring number, if we look at the data values we have, we can see that 83, that height is repeated 3 times. So I would say that 83 is my mode. We already have the median. The last thing we would need to calculate is the mean for another measure of center. For the mean, we're going to calculate the total of the heights and divide it by 17. And when I add it up, I get 1,349 for their heights divided by 17 would give us an average height of a Cavs player as 79.4 inches. So I can see that the mode of 83, the mean of 79.4, and the median of 79 are pretty close. So the mean of 79 and the median of 79 and the mean of 79.4 are very, very close. Looking at my box plot, it doesn't look like I have any values that are way off. So I think using the mean as a measure of center would be good. Like I said in class, we're going to practice a little bit more. I have on this next page 4 problems for you to try on your own. We will, I'll take a look at those on Friday, go through those. We'll work on some graphing and then working on some standard deviation as well.